Building retuning training was conducted by Ron Underhill and Gupong Liu, scientists at the Pacific Northwest National Laboratory. Classroom and on-site training for Maryland State Agency facility managers was conducted at Towson University in Towson, Maryland on June 17th through the 19th, 2014. This segment of training covers central utility plant heating.
So we want to talk about boilers. Is it on during a hot summer? Now, Gupong talked about being able to shut off your reheat systems. We had an experience in Kansas City, similar climate zone to here, hot, high humidity, 10-story building, south-facing area on the top floor, lots of glass, 95-degree day, high humidity. I expected that there would be no reheat going on that floor, 9th floor. And on all the south-facing perimeter of that building, 50% of the zones were in significant reheat mode. Okay, so you got to ask yourself, is that what I would expect? I got not only hot temperature outside, I'm on the south side of the building, I got glass, I'm picking up solar heat gain, and I'm reheating? And so the question you have to ask yourself is, why am I reheating? And why is my boiler on? Can I reduce my boiler temperatures? If I got to reheat, can I reduce the load on my boilers by reducing my supplier temperatures? Those are the things we would recommend. So, do we have a hot water set point reset? Can I reset my boilers? A lot of boilers you cannot reset because they're not condensing boilers. You might start having problems with condensation in the boiler box, and that might start affecting the corrosion, some things that you might be taking your boiler to a premature failure, which nobody wants. So typically what we see people running their hot water boilers down to is about 140 to 160, and a lot of people don't even like to go below 160. So how many of you have hot water boilers that are not condensing, and are you just fixing them, keeping them at 180, or are you doing any kind of reset?
If you set down to 140 for you, it has to do with the expansion contraction, and they don't usually have a problem. The manufacturer usually go to 140, but they won't go below that.
Okay.
For shock and everything else.
All mine are 180.
180.
You can't go below 180 or it will start condensing back. Now what you do is on a loop system, you can put that on a reset and drop that back down 100 degrees.
Yes.
But those boilers, you cannot change that or you will create the problems on the back of the boiler and have to replace the boiler.
How large are those, what you're talking about?
I've had quantities, 400 horsepower, steam boilers. I actually even have little McLean boilers right now that we tend to have an issue with that if I drop. They're aluminum-based boilers or coils in them, but they, trust me, I tried to do it in the manufacturer as well as my partner. You come back and
You don't go below 180?
no, I have to keep it around 180. I tried about 160 or 140.
To one what?
I run my boilers between 180 and 200 degrees, okay? Or 160, I'm sorry, guys, 160 and 180. And I can't go below 160, and I go as high as 180, and it's on a reset. And that reset will only do the loop, the outside loop, and that'll drop back in, from outside temperatures, low as, 100 degrees. Because
You do it through the mixing valve to do your loop temperatures?
yes,
Okay.
yep.
So if you don't have a mixing loop, then you're circulating that same hot water temperature, 160 to 180 throughout the building.
Yes.
Yeah. So that's why it's important if you got leaking valves and you got a loop that's got to be held at 160 to 180, and it's a 100-degree day, you don't want to
go far though on the
No,
boiler.
yeah. So anyway, great conversation, great discussion. The other thing I'll just add to that is your stacks. Cleaver Brooks and others, they recommend having a drain for your anything that's products of combustion condensing out moisture. And a lot of times they're not properly drained away, so you get that acidic acid going right back in your boiler box. We've seen that even on condensing boilers, some issues with where's that going. So something to pay attention to. Yeah.
Another thing you can do is you can lock them in low fire when you have to run them during the summer, so you have minimized the number of starts you have. Every time you start a boiler, it's equivalent to about 3 hours of run time at low fire.
Just to add more fuel to the fire, no pun intended, but if you got multiple boilers, they're piped in parallel. You got isolation valves that are automatic. We see a lot of boilers, 3 boilers, 4 boilers. I'm only running one, but I'm circulating hot water through every one of them. And so now I got losses up through the stack, through the skin. Creates a lot of inefficiency besides the short cycling like you're talking about, which adds to it. How many of you have hot water loops that are not boiler derived but steam derived? So you have a plate and frame heat exchanger or some sort of, okay, are you resetting those loops? Great.
Absolutely.
Good, okay.
On the outside.
Okay, great. Differential pressure set point reset. If you've got VFD driven pumps, if you've got a primary secondary, hopefully you're doing some kind of a reset. And then the last bullet there talks about temperature delta. What should we see on a properly sized boiler that's running for the appropriate load? 10 to 20 degrees. What do we typically see? If it's not, 2 to 4 degrees. So those are some numbers out of industry. So we talked about circulating pumps. Can we keep the boilers hot but shut off the circulating pumps? Depends on what your design is. You might be able to do that. So if we have that ability, can we keep the boilers hot but shut off the circulating pumps? Let the building cool down instead of baking the building at night. Again, it might be, you might have a limitation once you get to a certain temperature outside. You may have to activate your pumps, which we would understand. But if I'm just running them year-round without any regard to what the temperature is outside or the fact that I'm in a night setback condition, if I've got perimeter radiation and I'm running hot water loops because I've got to do reheat in the VAV boxes, can I go around and valve out my perimeter loops? Do I go around and valve them out? A lot of perimeter baseboard loops just run wild. We see a lot of fan coils. We actually saw some in this campus. I won't say which building, but we knew that it was a fan coil in a stairwell and it was circulating hot water. And so there's opportunities. Again, those would have to either be automated or manually, seasonally addressed. If we're going to lock things out, disable them, then we got to go back and re-enable them. Some of the reasons why we would want to have a reset schedule is, as I've said already, valve leaks. If I'm going to leak hot water, I'd rather leak 100, 120 degree hot water than 160 to 180 degree hot water. This is another one, third bullet down. Differential pressure in my hydronic loop can increase to the point that valves that say they're closed all of a sudden lift. And a lot of people kind of tend to overlook this, but differential pressure control on your hydronic loops is critical. Most valves have a pressure rating, and if I'm running 55 psi out, come back at 35, 20 psi differential, that 55 might be higher than what the valve is rated for per the manufacturer. So again, recommend that you look at what your pressures are in a closed loop and see if you're exceeding the vendor's maximum pressure on the valve, and see if that's why you got valves that are leaking. I've seen people go to the trouble of replacing valves because they were leaking, they thought, and then they put in a brand new valve and it's still leaking. Well, your hydronic loop pressure is running too high. Yes?
With the VAS, another thing that happens, you get wire draw. If you start running your valves for long periods of time below 10%, I usually say 5, but if you have a situation where you're going to open or heat a valve, I usually open mine more than 5 or 7%. Otherwise, I'll get wire draw through the valve over a couple of years. Mm-hmm. And then you got to replace the valve seat.
Yeah. Common on steam valves.
More common on steam valves than water, but nowadays, a lot of times your perimeter radiation, they use two-way valves rather than three-way valves. Mm-hmm. And they use your three-way valves on your reheats. Right. And then on your two-way valves, you'll get wire draw and you'll hear that whistling. Once you hear that whistling, your customer's really upset. Yeah.
So just like we talked about VAV boxes and the dampers and the chart that Gupong showed you earlier, most of the air dampers were less than 20% open. If you're looking at your trend data and you're seeing your reheat valves are less than 5%, 10%, 15% consistently on the low end, then it could indicate that you've got too much hydronic pressure, too warm of water. So all these things have an energy component to them, and it's an opportunity to say, you know what, maybe I need to reset my hot water loop if I can, my differential pressure set point if I can, and start taking advantage, especially if I got a VFD-driven pump. Great opportunity to save some energy, save some equipment life, extend it. So again, related to that, if I'm circulating hot water and I don't have to circulate 180, if I can circulate 120 140, especially this time of year. I can still satisfy my heating requirements, but do it in a way that's more stable. If I'm circulating 180 degree water, that valve cracks open, boom, fill up the coil. Now I'm discharging who knows what, excess of 100, 120, and that temperature quickly raises the space, and then all of a sudden it's responding. I'm closing back off so I can see the cyclical action. Yes?
Another thing I cheat with sometimes is I'll take a thermostat outside and I'll paint it black, face it towards the sun. The reason for that, during the winter time, when you have a nice sunny day and you have your hot water reset, it'll keep your building warm. But when it gets a cloudy day, everybody complains, and you'll automatically bump your temperature maybe 5 degrees when your hot water resets so that you don't have a cold situation. And that way you'll eventually learn your building. You'll decide if it's 5 degrees or 8 degrees or whatever the case may be. But if you don't have something along those lines, every time it gets cold, you're either always raising your temperature too high to compensate for the cold days. So when it gets a sunny day, you end up overheating your building. So you're always fighting that situation.
Oh, it's interesting. I've never heard of that. So.
Oh, okay.
Yeah, that's a great idea. Is that the space temperature or the outside temperature?
You take it outside temperature, just take a stat outside, just like you have outside, but you put it right towards the sun, you paint it black. And if you have at least a 10-degree difference, it means that you don't have if you have at least 10-degree difference, you have a sunny day.
Oh, I
But
see.
if you don't have a 10 degrees difference, then it's a cloudy day, and you're going to need more heat in that building to warm it up.
Okay, good. I've never heard of that. That's great. So some of the things that we talk about with boilers, again, the cautionary bullet there, if you don't have condensing boilers, you are limited. We heard 160. We have 3 large boilers that we rarely run below 180. I hate to say that. Bypass mixing loop is a great option if it's designed by the engineer, where you can keep the boilers warm and drop the temperature on the loop.
You know, one thing that we did, in speaking about boilers and steam that has been mentioned, we took reducing stations and actually set those up to a reset schedule. And it worked out well, you know, it just saved on our steam pressure because those reducing stations would actually run off 15 PSI.
Yeah.
And I was able to monitor reducing that and trending it to like 7 pounds
Yeah.
for a year and seeing that I was still maintaining. And I actually got it down to where I could actually maintain that reducing station to supply the air handlers at 3 PSI to 6 PSI. Being in the summertime, it would run at 3, and in my coldest days, it would run at 6. So it was able to reduce it from 15.
And that's an
pounds to 6
automatic reset? Or
Yeah, I did it on an outside reset schedule, and it worked out tremendously. It was
You
great.
bring all your water back, or is it just you throw it away, so to speak? I mean, when you get to that.
Actually, we did a couple unique things too. What we did with our condensate, we actually pumped our condensate back, okay, and fed it back into our DA tank. I mean, on that sense, but we did RO water and pumped that back as well to the DA tank. And that's how we made up our water. So we did some unique things, and this is at the EPA, so it was always a challenge to try something different. But it all worked. Was able to do in the summertime, take all of our chill water condensate and took that and on a $4,500 expense, was able to pump that back to the cooling tower. And the first summer we paid for it.
Nice.
You know, and it was, you know, something you could do very simple. We would, you know, all the air handlers were lined up together, so it wasn't like you had a long run of PVC pipe or all that. We just created a reservoir, pumped it to the reservoir, then pumped it up to the cooling tower.
That's a great idea. Don't tell the people that want to recover that for flushing toilets.
That's right. It's things that they're right out there, and you can grab them.
Yeah,
Just
that's
think
great.
about it.
Excellent ideas. Thank you for sharing those. I really like your idea about resetting the steam pressure. We encourage people, you still have pneumatics. If you've got pneumatics, we constantly find pneumatic systems that are set for 100 PSI, and you get out into the mechanic rooms, everything reduces down to 20. And unless you've got some pneumatically driven valves or dampers that require 190 PSI, it's another opportunity to say, okay, can I reduce compressed air is notoriously inefficient. Steam leaks, if I'm going to leak, if I'm going to air leak, do I want to leak at 100 PSI or 60? Do I want to leak at 15 PSI on steam traps, or can I reduce it? I'm still leaking, but not at the same rate. So kudos to you guys. That's excellent. So hopefully some of you that are here are maybe getting some ideas that you can take from what this gentleman shared. Yeah, that's awesome. So the other thing is, this may or may not be in the slides, but is there anything I can do in the summertime? I gotta have reheat in the building. My steam or my hot water system's, like I said, serving radiation. Can I valve it out? If it's steam derived, can I shut down steam that's going to my preheat coils, my other heating coils? I don't need to worry about piping hot water to all these coils. I just need it for my reheats. But yet we're probably circulating water, or we have steam going to all these other coils, and we constantly see this in buildings. I can't do a summer steam shutdown, don't ask me to. I can't do a summer hot water boiler shutdown, don't ask me to. Okay, I won't. But that number one tenet is if you don't need it, turn it off. I can't turn it off. Okay, can you reduce it? Well, how do I reduce it? Go and valve out the coils that you don't need. You don't need a preheat coil, right? It's not 20 degrees outside. You don't even need the heating coils in your air handling units. If you're able to do the reheat at the zones, then you should hopefully be able to do some isolation. Well, now that's more work. I got to write a seasonal PM. I got to do, yeah, you're right. Nothing's for free.
But your BAS should do that.
Maybe. If you programmed it to do that, it should. But again, the question is, do I got valves that are leaking by? We're assuming that nothing leaks. And I hate to tell you that, but you can't assume that.
No, I'm assuming maintenance-wise, I would go out there and inspect to see what valves are leaking so I can replace them. It's easier to replace a roll of head during the summertime.
I know. I'm with you. I'm with you on that. So there's the optimal world, and then there's what these guys face with limited resources. And sometimes all you can do is valve things out, but then you got to remember to go valve them back in. So sometimes the easiest path to least resistance is just leave it valved in, because next November when it gets really cold, I don't want to get in trouble for forgetting not to valve it back in. So just some suggestions, some ideas. So when we're looking at the trended data, we want to look to see if the differential pressure or set point is constant. Does it vary based on some feedback, whether it's outdoor air or zone valves? If we're looking at hot water temperature resets, do we see a constant 160 to 180? Can we drop it during the summer? Condensing boilers are a huge opportunity. How many people have condensing boilers? Okay, so you should be watching your condensing boilers, specifically the trended data on the return temperature coming back. If it gets above 135, you can look at the vendor's charts, but you start losing efficiency.
If you can go down to 120, or the case would be, why go to 120 to 140 when you go to 120 to 180? And then you can start the boiler up at 120, keep it in low fire. When it hits 180, it shuts off, but now it doesn't come back on until it gets all the way back down to 120. And so it minimizes the number of starts of your boiler.
Yeah, I mean, that's a great idea. Again, if we're not leaking, that's a great idea. So there's a lot of ways to look at it. That might get into some of the thermal expansion contraction when you're going from 120 to 180 versus a reset that's...
Most boiler manufacturers, their concern more is about the sudden starts, and the constant
Yeah.
starts and stop or explosions. They would say every time you start a boiler, it's an explosion. So if you can reduce the number of explosions, the better off you are. There's 30,000.
We don't want to use
There's
that.
30,000 boilers a year that blow up in this country.
Yeah. No, I hear you. That's good comment. So looking at this chart right here, the red line is the loop differential pressure, and then the purple line is based on the left axis. The right axis is the heating valves, the maximum heating valve position. So this might be from a building that's got 100 reheat valves. And so what we see is based on the DP setting of 9 PSI, it looks like the red line, we see that the maximum heating valve based on the right axis is running right about 45% open. So there's an opportunity to say, you know what, I don't need 9 PSI. I could have it automatically reset. And you see that before and after as you move from left to right on this chart. The DP set point dropped significantly from 9 down to about 4, maybe as low as 3. I'm not sure what happened there on the 13th, Friday the 13th, something went bad. But anyway, you can see the difference. And so we're dropping the DP, the loop set point, saving some pumping energy, and getting the valves to go a little more wide open, avoiding that, if there's some issues with wire draw. And then this basically shows the savings from doing that The pre was around 10 psi, a constant set point. The post was about a 3 to 6 psi set point that automatically adjusts. And then your pump speed, the blue triangles show you where you're running about 50 to 60, almost 70%. And it increases as it gets colder outside, which makes sense. And it drops significantly. So again, based on what Gupong shared earlier with the affinity laws, there's probably some substantial savings. We don't know the size of this pump or pumps. This is a little bit different. This is a fabricated chart. I apologize, it needs to be fixed. I keep saying that. But if I'm resetting, I'm not going to raise, the blue line is my supply temperature. I'm not going to increase the supply to get a wider delta. What you can see, it's just for demonstration purposes that we show a tighter delta, and after readjusting, we want to get that difference between what's going out from the hot water loop, the boilers, and the return coming back. If this is a condensing boiler, we'd want that return to be less than 135. That's why I'm hoping that if we implemented this on a condensing boiler, that we would have done things to cause that return temperature to drop as well. So this is a quick test. Hopefully we've given you enough information here. You got a hot water converter, steam. Set point is 140 to 180 degrees. This is a 24-hour trend, so that's just one day. It shows the 25-degree variation between what's going out and returning. And again, outdoor conditions, sunny, 55 to 85. It's from the same location we talked about earlier this morning. So this is California. And the hot water loop resets based on anything above 60 degrees. So once it gets below 60 degrees, it's locked at 140 degrees. So any suggestions for low cost, no cost change? It runs 24/7. We've told you that already. This is a Monday. We didn't tell you every day of the week, but I'll just tell you right now, it runs every day of the week. And it runs as low as 140, and it's steam. So it's not a boiler that can't be reset. It's a converter. So there's no concern about damaging a boiler. Anybody have any suggestions? Reset it further. Yeah. Turn it off. Okay, great. Great suggestions. So, hot water temperature too high, too low? Is the loop tuned properly? Should we raise the hot water high limit set point? Lower the low limit? I think we heard run it lower. Add a lockout or put it on a schedule, turn the pumps off. And yeah, any number, any one of those things. Lower the temperature. Instead of resetting it down to 140, reset it down to 120, maybe even 100. We have some hot water loops that we run as low as 80 degrees. Now maybe that's too cold for what you guys are doing here if you're overcooling to dehumidify. But if it's steam fed through a heat exchanger. The problem with this site right here, and I'll just tell you real quickly, because this is something that you may or may not have in some of your buildings. They have their piping for their hot water loop is Victaulic fittings. Anybody have an experience with Victaulic? And yeah, everybody's laughing. I'd be crying, but a lot of Victaulic design systems, the elastomer, the material that the seals are made up, they don't tolerate expansion, contraction real well, and they start to leak. Not a good thing in public buildings, water damage, mold. You guys, everyone talks about mold back here with high humidity, and I generally say, okay, yeah, is your mold from the humidity or is it from leaks from other spots? And yeah, but anyway, it doesn't really matter. Mold is bad. So Victaulic, at this site, they can never shut it off, and they can never let the temperature get below 140 for those reasons. Very sad, very unfortunate. So what have you guys done with Victaulic design systems? Yeah, no, yeah.
We only use it for cooling.
And here's the question. Okay, I'm going to run it 24/7 because I don't want the temperature in the loop to I don't want the flow to stop. I don't want the loop to cool down. And my comment is, can you guarantee that you'll never have a power outage of any sustained length or failure of your motor control center, your switch gear, where you just lost power to your pump, so you can't even circulate that hot water to keep it at 140? I bet you can't guarantee it. So you're telling me you're doing all this, you're expending all this energy to keep the loop at 140 to 180 so that I don't have leaks. That's a Band-Aid. That's a Band-Aid. I'm sorry, but the $20,000 fix is the long-term fix. Now you can do things like shutting them off. So